Number 6, find the height of a square pyramid with a volume of 128 cubic inches and a base edge length equal to the height. Okay, so here I have a square pyramid, and notice that it says that the base edge length is equal to the height. So because it's a square, we know that the side lengths measure the same number, so I'm just going to call that side x. And this side is also x because it's a square, so the side should be the same. Now the height is equal to the base edge. So if I draw the height in here, remember the height is always perpendicular to the base, the height is also the same as the base. So this also measures x. And I know it's kind of hard to see, but here's the height, if you can picture that in your pyramid. So when they're asking us to find the height of the pyramid with a given volume, let me go ahead and fill in what we have. This would be area of the base times the height, and then we're going to divide this by 3. Now we know that the area of the base, because it's a square, would be length times width. So that would be x times x. And we also know that the height measures the same. So once we have the area of the base right here, we can multiply that by the height, which is x. And then we're going to take that and divide by 3. Notice on the top I have x times x times x. That is the same thing as writing x to the third power. Divide that by 3. Now they did tell us what the volume was. The volume is 128, so we can plug that in for v. So now I only have one variable. I can go ahead and multiply both sides by 3. When I do that, I'm going to move my work over here. I get 384 is equal to x cubed, and so now we're going to cube root this. Whoops, I can get the little 3 to show up here. There we go. Sorry about the pen. So we can cube root this, and remember you can find that button by hitting the math button on your calculator. And we're going to take the cube root of 384, which ends up being about 7.3 if we round. Once again, sorry about that pen. This is equal to x. Now, if you had this question on the test, you can always go back in and plug it in and make sure that it works. If you type in 7.3 times 7.3 times 7.3 divided by 3, it should equal 128. Now remember, we rounded, and so you might be just a little bit off. But that's a good way for you to check your work when you're doing the test. Number 7 says find the surface area in terms of pi of a sphere with a volume of 288 pi. I'm going to go ahead and write the equation for volume of a sphere because that's the information that I'm given. Okay, so here to solve for the radius, we're going to divide both sides by 4/3 and by pi. Now remember, when you divide by 4/3 and pi, make sure you put that in the parentheses. If not, the calculator is going to think that you only want to divide by the 4/3 and not the pi. Alright, so now we're left with r cubed is equal to 216. And then we're going to take the cube root of that, which is equal to 6. So that means the radius is 6. And so now that we know what the radius is, we can go ahead and take that. Oops, sorry about that pen. The radius is 6. We can take that, we can plug it into the surface area equation and find the surface area in terms of pi. So the equation for surface area is equal to 4 pi r squared. Alright, so let's go ahead and plug in our radius, which is 6. So it's 4 times pi times 6 squared. Okay, and that gives us 144 pi. And we're going to leave it in terms of pi, so we don't want to multiply by pi. We want to leave that out. Okay, and this would be centimeters squared. Okay, for number 8, I know the whole question doesn't fit, so I'll go ahead and just read it. The height and diameter of a cone are multiplied by 3. Describe the effect on surface area and volume of the cone. So once again, just like we discussed on problem 3, since we're changing all of the dimensions, then we can follow this rule here. This rule says that if you change all of the dimensions, then area will change by that number squared. So because we're changing all of the dimensions by a factor of 3, so we're multiplying the diameter and the height of a cone, then we know that the area will be 3 squared times bigger, or 9 times bigger, because we take that number and we square it. So 3 squared will be 9. So the area of this bigger cylinder will be 9 times bigger. For the volume, we know that if you change all the dimensions, then the volume will change by that multiple raised to the third power. So since we're multiplying all the dimensions by 3, then the volume will increase by 3 to the third power, or 27. So the volume will be 27 times bigger than what it used to be. So So as long as you change all the dimensions, you can change this rule. If you don't change all of the dimensions, then you have to look back at what we did at problems 1 and 2 on our review. Okay, number 9, find the volume of the figure below. So right here in this figure we have two pyramids, and they're square pyramids. You can see the little congruency markings here. And then we have a cube here in the middle. So let's go ahead and start off by finding the volume of the cube. I think that'll be the easiest one. So the volume of the cube, it's the same as a prism, area of the base times the height. So because it's a cube, it doesn't matter which base we choose. Let's go ahead and make this our base shape for the cube. So the area of the base, this will be 9 by 9. And then we're going to multiply that by the height. And since it's a cube, we know that the height will be 9 as well. So here, the volume of the cube ends up being 729. Now we're going to go ahead and find the volume of this pyramid. And we're going to start off with this one right here. So the equation for volume of the pyramid is the same as a prism. We just have to end up dividing by 3. So first off, area of the base. So right here, this is our base. Now remember, this is part of that cube. So the area of the base will be 9 by 9. Okay, that's the length and the width. And then we're going to multiply that by the height. Now notice they don't tell us the height. They do tell us the slant height. So we need to find the height, which is perpendicular here to the base, right there. So we can do Pythagorean theorem right here. So see if you see this triangle right in here. I'm going to go ahead and draw this triangle out here so we can see it. So we've got this right triangle. I'm just rotating it right over here. They did tell us the slant height was 15. And then down here, if you notice, this part is half of the side. So this will be 4.5. Now we can just do Pythagorean theorem. I'm not going to go ahead and show my work. You guys know how to do that. So when we do Pythagorean theorem, we get that this side measures about 14.3. Okay, so we're going to go ahead and plug that in for the height. Here we have 14.3. Whoops, that's not a 3. Sorry about that. The pen sometimes acts up. Okay, divided by 3. Let's get our volume for that one. So the volume for this pyramid on the left side is 386.1. Okay, all right. I'm going to erase some of this because we're running out of room here. Now let's go ahead and find the volume of this pyramid right here. So volume equals area of the base times the height divided by 3. So once again, the base shape is a square because it's part of this cube. So we know that it's going to be 9 times 9, that's area of the base, times the height. Once again, they didn't tell us the height. It's right here. We know it's perpendicular to the base. Now we can make a right triangle right here. So we can go ahead and do that right over here. I'm just going to zoom in so we can see what that triangle looks like. They did tell us the slant height was 19, so that's right here. And this bottom part, just like we did before, that's 4.5. That's halfway across the square here. And then you would do Pythagorean theorem to find this side length. So I'm not going to show the work for that because we all know how to do Pythagorean theorem. When we do that, we get that this side measures 18.5. There we go. So let's go ahead and plug that in for the height. We have 18.5 right there. And then we're going to take that and divide it by 3. So then the volume for this pyramid is equal to 499.5. So now let's go ahead and find our total volume. I'm going to put here V with a T. That's my total volume. And we're going to add this one, and this one all together. This is our total volume. And that gives us 1,614.6. And that's supposed to be a 4. This is a new pen we're trying out. It's not working out too good. Okay, so make sure you find each piece, and then you find their volumes to find their total. Number 10, find the volume of the regular hexagonal composite figure. So on this one, gets a little bit more trickier because our base shape here is a hexagon. So we're going to have to find the apothem. All right, so I'm using technology here because I know I can't draw a hexagon, and we're just going to do the math on this shape. Okay, so here we know that the side length is 5. And we're going to have to find the apothem right there, which is perpendicular to the side. Now remember, with the apothem, we have to find the central angle. Here, we would end up making 6 triangles. So each of the triangles would be 60 degrees. And when we draw the apothem, that would cut the angle in half. So this angle right here ends up being 30 degrees. Now we know that from here to, here, that's going to be half of the length of the side. And since it's regular, all those sides are 5. So this ends up being 2.5. Now you can use trigonometry if you want to find this side length, since you know the angle. Or if you remember your special right triangles, you can remember that there's a ratio for this 30, 60, 90 triangle. So because across the 30 degree angle, this is 2.5, then we know that across the 60 degree angle, this would be 2.5 square roots of 3. See if we can fit that right in there. Alright, so we have the information that we need. Let's go ahead and start finding the volume. So the equation for the volume here is going to be area of the base times the height, and then divided by 3. The area of the base, we know for a regular polygon, is 1/2 times the apothem, which we just figured out is going to be 2.5 square roots of 3, times the perimeter. So we have 6 sides, and each side measures 5. So that's 30. Then we're going to take that and divide it by 3. So the volume, okay, so that's just area of the base. Now we have to multiply that by the height of the pyramid. Now notice they don't tell us the height, just like on problem number 9. So we're going to draw it right here, and it's always perpendicular to the base. So we're going to have to do Pythagorean theorem. And notice this right here goes from the side, so from here to the center. That's your apothem. So this segment right here is 2.5 square roots of 3. And I'm going to go ahead and draw that triangle out, and we can do Pythagorean. So we don't need to draw it out. Here's your right triangle. We can do Pythagorean theorem. I'm not going to show the work for Pythagorean theorem since we all know how to do that. 14 would be your hypotenuse, and then 2.5 is one of your legs. So the height of this shape ends up being about 13.3. So we're going to go ahead and put that right here. So we're going to take that, and we're going to divide this by 3 and get our volume for the pyramid that's on the left side. I know there's a lot to type in here. So when we're done, we get that the volume of this is 287.95, so basically 288. Now we have to do the volume for the pyramid on the right side. Now the volume for the pyramid on the right side has a different height. So this height goes from here, same place, to here. We have another right triangle. This is still 2.5. We have our right triangle, and we can do Pythagorean theorem. So I'm not going to show the work for that. I am going to erase this just to make more room. And I get that the height of this right here is 6.7 when you do Pythagorean theorem. So let's go ahead and plug all of this. It's going to be the same thing we have here. The only difference is going to be the height of your pyramid. So we're still doing 1/2 times the apothem, which we found out that was 2.5 square roots of 3, times the perimeter, which we said was 30. And then we have to multiply times the height of the pyramid, which is 6.7, and then we're going to take all of that and divide it by 3. Once we get that, we have to add these numbers together. So let me go ahead and write this. So our total volume comes to 433.01, or if you just did 433, that's just fine.